Waves. What are they? Where do they come from? Sammy, you've now set foot in 2 oceans and the Caribbean Sea. What causes the changes in the height of the water, or the crashing of so many millions of gallons of water onto the beach? What are waves? Waves, all waves, are the result of energy moving. You can think of waves as one of the universe's ways of showing us energy being transferred from one location to another. Waves over water are mechanical waves, typically caused by wind. A mechanical wave needs a medium to travel through. That means it needs to move through something. In this case, that something is water. What happens is the huge number of tiny little water molecules in the ocean are being pushed by the wind. They are catching the wind's energy in a way, and they come up against other molecules of water and push them in that same direction that the wind pushed them, while being pushed back by those molecules that they just collided with. The wave moves forward, and the molecules can kind of stay in the same place. That's why, even when the wind dies down, there can still be waves. Those waves might have started somewhere far away, where it was windy, or a long time ago, when it was windy. Those are called swells, waves when there are no winds. You'll notice that some waves are bigger than others. They have more energy. You'll also notice that the distance and time between each wave cresting and falling might be different. That's known as wavelength. Sitting out here on the beach, Sandy, we can learn about other kinds of waves too. Listen to that sound. That thunderous, rolling roar the ocean makes. That's the sound of the waves moving. But sound is also a wave. In fact, it's a lot like ocean waves, as it is also a mechanical wave. The sound waves you hear in your ear are in fact waves of energy pushing the air around you. As the wind pushes against the water, so the water pushes against the air, which then pushes against your eardrums. Your eardrums vibrate as the air outside pushes against them, and those vibrations are then amplified in your skull and interpreted by your brain. Your brain turns those vibrations into all the complex sounds you hear, like the roar of the ocean, or music and singing, or even the sound of my voice right now. That's right, my voice is being amplified by the speakers right now, and pushing the air around them into your ear in a way that your brain can interpret. Remember the wavelength we talked about just now? The way your brain interprets sound is based on its wavelength, the space or time between the crest and trough of a wave. A higher pitched sound has a shorter wavelength, meaning more air is vibrating into your ear per second. A lower pitched sound has a longer wavelength, meaning less air is vibrating into your ear every second. The measure for that number of times a wave crests and falls in a second is called frequency. So, a sound with a shorter wavelength has a higher frequency, and thus a higher pitch. Because sound travels through the air at pretty much the same speed everywhere on the surface of planet Earth, which is 1,236 kilometers per hour, or twice as fast as the plane we took to get here, we can all recognize the same notes in a piece of music pretty much the same way. Sound can also travel through other mediums. It's a mechanical wave, remember? It actually travels faster through water than it does through air, and even faster through some solids, like aluminum. But for you to hear it and understand it, it has to touch air first, so that air can push into your eardrum the way your brain is familiar with. Waves. Pretty neat, right? Invisible forces that make things move. Things that you can touch, and things that you can hear. But what about the things you can see? Look out into the ocean, Sammy. Everything that is coming into your eyes is also waves. Different kinds of waves. Light waves. Your eyes are like digital cameras, like the one I shot this video on, but much more powerful. Light waves enter your eye just like the air that enters your ear to become sound, and hit millions of little light receptors in there called rods or cones. Those rods and cones then send signals to your brain. Your brain interprets these signals and creates all the shapes and colors and shadows and shades you see. Close your eyes. You see almost nothing, right? Or go into a completely dark room. Nothing. Everything you see because of light. Because it is either emitting light, like a light bulb or a fire, or reflecting light, like a piece of glass, or any surface in daylight really, or the water, or even the moon. Light waves are different than mechanical waves. They don't need to move through something, and they don't need to transfer energy from one pile of water molecules or air molecules to the next. They can move through a vacuum, which basically means they can move through nothing. Or they can move through air, or water, and many other things. Light waves are called electromagnetic waves because they move through an invisible and omnipresent medium called the electromagnetic field. You can't see it like you can see water, and you can't smell it like you can smell air, and you can't hear it or touch it, but it is there. The speed of light waves doesn't change that much through air or water. Just like sound, light differs by wavelength, or frequency. Instead of pitch changing like it does for sound, different wavelengths for light produce different colors. Light with a longer wavelength, or lower frequency, looks redder to your eyes. Light with a shorter wavelength, or higher frequency, looks bluer to your eyes. All of the colors of the rainbow lie in between. There are also lots of light, or electromagnetic, waves that you can't see. If the wavelength is longer than the lowest frequency red you can see, it's called infrared. If the wavelength is shorter than the highest frequency blue you can see, it's called ultraviolet. There are many animals that can see light in these spectrums, so the world must look very different for them indeed. Different materials, like water or wood or rocks or different metals, all reflect light in different ways. When they reflect light waves, they bend them, changing their wavelength. That's why different things have different colors. In the dark, you can't see colors, but in the brightness of day, colors become visible and vibrant. Colors are one of the ways we human beings can understand a thing or distinguish it from the next thing. We can point to something and say, that's red. But all the colors you see are the result of how things in the world reflect and bend light. So when we look out into the ocean, Sandy, what we're seeing is the light from the sun reflecting off of a whole bunch of different things. That's what gives us the colors we see. The light waves come from the sun. They hit the molecules that make up the air, which bends some of the light waves to make the sky look kind of bluish. Those waves in turn hit the water, which reflects most of them back, so the water also looks bluish. The sand you see in front of you catches the sun's light waves and bends them in such a way that they look yellowish. The plants and algae in the water bend some of the sun's light in a greenish way. The rocks bend the sun's light to look kind of brown, and so on. Like your eyes and brain, the camera catches all those bent light waves and interprets them, and records them so we can see them later on a screen. The screen you're watching this on is pushing out light waves of different wavelengths for your eyes to see again. So, Sammy, when we take you to the beach, you get to see waves, hear waves, and touch waves. In a way, everything around us that we can perceive is defined by waves. There are some scientists who think that even matter, the stuff that makes up everything, is also just waves. The fact that it exists at all, and the place that it does, and the time that it does, is defined by a probability wave. That the sand, the ocean, our bodies, our brains, our eyes, our ears, the earth, the sun, all the other stars, the galaxy, and the whole universe are just waves of chance, or probability. But that's another discussion that someone much smarter than Daddy should probably pick up. Waves. They're all around you.